In case it wasn't clear from the write-up, but can everybody hear me, by the way? Yeah. In case it wasn't clear from the write-up, this is the cursed room. The session after this got cancelled because the speaker couldn't make it. Then the session before this got cancelled because the speaker couldn't make it. And then yesterday morning, this session got cancelled because the speaker couldn't make it. So we're basically just in the middle of the twilight zone here somewhere. Hopefully we all make it out alive. So basically what I'm going to do here, I've been thinking about making a talk at some point called Stone Age to Serverless. And I thought I may as well, since I'd got a few slides already about the serverless side of things, if I add a rant on the front of it about why nobody is using serverless yet, then we might get somewhere near half an hour. And if anybody has any questions at any point, or heckles, or even questions that are more of a comment, to be honest, then fire away, and we'll see how we get on. So yeah, this is the first part of my amazing slide deck. But once upon a time, back in the Stone Age, when I was a young developer, I actually had real tin in my own house, and I served stuff on it, and I had it connected up, and I had the little websites on it, and yeah, it was brilliant, except for when the hard disk broke or when it got hacked or anything like that. So I started moving on from there onto having it on a dedicated server in, I forget which ISP it was in those days, but moving on to ISP's thing. Then they started inventing these VM type things. So so it was still kind of Stone Age, but we had these wonderful things called VMs. So at least you didn't have to worry about the hard disk failures so much. But you still got hacked and all that sort of stuff. Now, roll on a few years. I'm a Microsoft MVP, so I started using Azure right at the start when it was originally only platforms as a service. They had no VMs at all. So essentially, I was pushed down the route of taking my code, my websites as they generally were in those days, and taking just the website bit, just the code, deploying it up to the platform, and letting the platform worry about the web server and the operating system and all that sort of stuff. Brilliant stuff. Then software as a service started coming in, so you could start using. These days you can use all sorts of amazing AI and ML services, and there's a million and one software as a service things around. Moved on from there, and then containers started happening. But I was starting to think about containers, and what happened was I had a system I was building, which I built on platform. And with platform, what you have to do is you have to scale up and down relatively manually. You either have to sort of predict when the spikes are and scale it up yourself, or you have to set metrics to say, okay, if the CPU goes too high or the memory goes too high, roll me up another instance, and then when it starts, the load starts decreasing, roll it back down. So I'd been building this thing, and I'd been having some real trouble trying to get that side of scaling of things working in a cost-effective manner, because I had all sorts of different little microservices running, and they were not, trying to run them in just a platform, which is essentially a server under the bonnet. It was getting difficult. So containers came along, and I was thinking maybe I should try these container things, but this Kubernetes, Docker Swarm, Mesos things were seemed all a bit complicated. And then they introduced this thing called functions as a service. And I looked at that, and that was exactly what I'd been wanting. So I started moving on to functions as a service. Now, the reason this is a rant is because I've been through all this process, and to me this seems the most natural thing in the world. So I gave a talk, which you'll see most of the slides of shortly, about what serverless is and how it's just a little incremental move on from platform as a service. And then I discovered, when people ask me questions, Heroku has been around for 11 years, and still everybody who comes along and says, I've moved to the cloud, what they mean is, I've got a VM and I've moved it into Amazon or Azure or Google. Nobody is using the cloud as a flipping cloud. So yes, that's the right. Just a quick show of hands. Who here is actually using cloud services? Right, so most people. Who is using infrastructure as a service, so VMs? Who's using containers as a service? Only two. Is that sort of just Kubernetes, managed Kubernetes stuff? Yeah. Yeah. Who's using platforms as a service? So five. And who's using serverless? Yes. So yeah, if anybody's, by the way, been to Dave Anderson's lightning talk, he probably did this all much better than me, but much quicker. So, so you should be using this stuff. Please use the cloud as it was intended to be built, not just as a hosting engine. So yeah, I will now move on to the serverless bit. So yeah. First thing about serverless is, everybody says, yeah, it's serverless. Yeah, it's got servers. Yep, it's got servers. It's built entirely on servers. You're not going to get rid of them. The thing about it is that you don't need to care about the servers. You don't need to manage anything. You don't need to scale them. You don't need to know how big they are. You don't even need to know what operating system they're running. You just need to put your code on them, and it scales up and down. The really nice thing about serverless is that you pay purely for the compute time and the memory that you use. So essentially, you're being charged by the number of the number of milliseconds of CPU time you use, multiplied by the amount of memory you use, and there you are. And that's just down at the function invocation level. So literally, if you don't use it, you don't pay anything. If you run one function that runs for 5 seconds every day as a timed job, you'll pay basically nothing. On the other hand, if you're building a little startup on this and all of a sudden you get front page of Hacker News or whatever and everybody piles in, your scale suddenly goes through the roof, and again you pay for exactly what you're using. So you only have to pay for anything when you become successful, and you don't have to do anything different at all. Excuse me. Sorry. Now, the main thing I'm talking about here is functions as a service, which is the code side of things, but a lot more things are being rolled into the serverless umbrella, mostly by the marketing departments, but essentially there's a whole load of stuff where you get exactly the same thing of paying for usage and automatic scaling. So you can get data. Amazon now have a effectively serverless Postgres service where you pay for the amount that you're storing and the amount of throughput that you're putting through. Azure have Cosmos DB, which is almost serverless, except that you have to pre-provision your maximum amounts, but it's still, it will scale as far as you want. You've got workflow solutions so that if you've got services running, you can plug them into the workflow and send your data around. Software as a service is becoming more and more serverless these days. So rather than just subscribing on a monthly fee, you can pay for, if you're using something like AI or ML, you'll pay just for the amount of time that it takes to process your model. And the interesting thing is that, Brendan Burns, who's the guy who founded Kubernetes, recently did a blog post saying that the future of containers is serverless as well. So those of you who are thinking of moving to serverless, moving to containers, you'll hopefully get the serverless model going on there. You won't get all the benefits of functions as a service, which is my preferred thing, but there you go. Everything's going serverless, so you've got to start paying attention here. Right. Any questions so far? Anybody want to object to what I'm saying? Yes.
Mark, you mentioned infrastructure as a service in the kind of quick write-up, and I guess some of those definitions of how the different Azure products fit into which is a platform and which is infrastructure and which is...
Yeah, the different, right, okay, so the question is basically what's the difference between infrastructure as a service and platform as a service and the other things. Infrastructure as a service means that you're using the cloud as a data center, so you've got the networking and stuff and you've got the hardware, but you're just sitting your thing on top of that infrastructure, so you've got a VM, the operating system is yours, the upgrades are yours, it's entirely your own box. Platform as a service is where you're uploading, if you think about your project that you're building, you're uploading that project to the platform. So quite often you will deploy by going through some sort of CI process where what happens is that at the end of the day you commit to Git, it goes through, and then that code from Git is what goes to the platform. And although you probably know whether it's Windows or Linux, that's managed for you, so you automatically get operating system upgrades and all the rest of it and all the security stuff, so you don't have to worry about that level. Where this takes you is that you don't have, as well as not having to worry about that, you also don't have to worry about how many of those, how many instances of your platform you're provisioning. So, does that make sense? Yeah.
Just to follow up on that, you said object of the project. Could a whole company run on that platform as a service? Or a company is just a bigger word.
Could a whole company run on project platform as a service? Yeah, I mean, you won't take your whole, you generally won't take your whole company, you won't have the whole solution, what you want to call it, with all its individual projects and just upload the whole thing to the platform, probably. What you're ideally doing is taking, if you've got a website, you'll upload that as one platform. If you've got a back-end process, you'll upload that to a separate platform and you'll scale those separately. But there's nothing to stop you if it's in one single deployable unit. Yes, you can deploy the whole thing to a single platform service. Yes, you just probably if you've got any size of a thing, you'll probably have more than one deployable unit going on. Right. Okay, so functions as a service, which is where we get into the fun bit. The way it works is essentially that you've got a function. As you know a function in code, literally just def this thing, this bit of code. The way functions as a service works is there will be some trigger that causes that to run. So it might be a timer trigger, it might be an HTTP trigger. So if you've got a webhook, for instance, could trigger it. It might be when a file appears in your storage bucket. It might be when a row is inserted into a database. Depending on which provider you're using, there'll be a slightly different set of triggers. But basically, when something happens, your function runs. It runs for a few seconds probably, and then disappears again. There are the three main cloud providers all do this. So you've got Azure Functions, you've got Amazon Lambda, and you've got Google Cloud Functions, which I think might even be out of beta now. I'm not sure. And then you've got a whole load of open source implementations as well. So you've got OpenWhisk, FaaS, who apparently one of the contributors works for Puppet in Belfast or something. Yeah, all right, okay. I forget who told me that, but yes. And then a whole load of other things. Kubeless, as you can tell from the name, is basically running on a Kubernetes cluster, but managing the scaling of that for you. And even Oracle have something. That's actually a dig at a friend of mine who's gone to work in developer evangelism for Oracle because he said he wanted a challenge.
They own Iron Functions?
They own that, do they? Okay.
Yeah.
I don't keep track of all the different names, but yes. Yes, I mean, I think IBM have one as well, which is OpenWhisk under the covers as well, I think. So, yeah, you don't want to use it, but... And, so this is effectively what you're looking at. You've got your function there, you've got your code, little thing with an input and an output. So your trigger runs it. You potentially from that trigger will pull in some input. So for instance, if you pass, the way that works, I'm doing this all in the Microsoft way, so there will be slight differences in the way that Lambda works or stuff. But essentially in the Microsoft world, you get a trigger. If that's got an ID in it or something, then you can then hook up an input to say, please also give me, the blob or the database table or the document from the database that corresponds to that ID. So that then just gets passed in as a parameter to your function. You run, and then the return value from your function, or multiple out parameters if you're using a language that supports that, then can go and either trigger another function or drop something in a queue or create a new blob. You can even send emails and all sorts of rubbish. I think you can even insert rows in an Excel spreadsheet these days in Office 365 if you really want to. No, true. And so you take then your functions and you start hooking them up. A function is sometimes referred to by some people as a nano service, but you can then hook those functions together into a microservice. So we're heading for microservice-based architectures here. Doesn't necessarily need to be exactly the same microservice-y type thing that you're thinking of, but essentially you're putting together again a deployable unit of code that works together into a little service. So this is just an example of something I've done before. You've got a timer trigger which runs every 15 minutes or whatever, goes and reads a feed from the interwebs, pulls out the images, and when one of your outputs is an image, that can then trigger another function which then creates a thumbnail of that and drops it into a separate bit of image storage. And then similarly you can take the text bits, drop it into a document database, and then at the other end you can have an HTTP trigger which effectively makes that an API request, and then that can pull in the information that you processed earlier, and hey presto, you've got a little thing which is doing background processing and then serving API requests off the back of that. And again, if you've got something like that, you only pay for the amount of time it's running. So if nobody uses it, you only pay for that 15-minute polling job. The nice bit, again, this is Azure specific. They've now got a thing called durable functions. What this is for those more complex situations where, for instance, if you wanted to pull in 2,000 different feeds and then aggregate them in some way before you did something, that's quite difficult to keep track of if you're firing off 2,000 async functions, and then you need to then wait until they've all finished by keeping track of them all, some sort of polling mechanism, and then once they're all done, then you go and fetch the outputs and do something with that. So what they've introduced is something called durable functions, which handles all of that for you. So you've got the fan out, fan in, where one function can trigger a whole load of parallel functions, and then that will all trigger one function again at the end. They've also got various other patterns, including one which actually will poll an HTTP endpoint for you until something has finished working and then continue. And they've even got ones for human interaction where somebody has to press something manually at some point to approve a workflow or something like that. But that, in particular, fan out, fan in bit, that's where I decided that, in fact, I reckoned I could actually build anything I wanted on serverless. There was no reason that I could think of for me not to just use serverless code, software as a service for where applicable, and leave even the platform things behind and the containers behind. And any more questions from at that point? No. So this is the point where people who, particularly the ones who haven't had platform, sort of start to think, yeah, great, but what's going on here? Going back to my rant, people are very, very attached to having a box that they can see, that they can remotely access and go in and look at exactly what's going on that box. You have to let go of that baggage. You have to let go of that idea that you're managing that machine and looking after that machine and that everything's happening on that machine. You need to start thinking of just your code as running on the cloud, and the cloud is owning that for you, and you just have to trust it. Because believe it or not, the people who build the clouds are actually probably even better than your IT team. And they may argue about that, but to be honest, on balance, the chances are that they are better than your IT team. So Yeah. So this is how it works. You do actually get a local development environment, so you can set up a local functions project. You can create a function, new function from the CLI. You can then launch that in local debug mode and set up a local environment for your local testing. So you don't necessarily have to launch the whole thing on the cloud and start debugging and stuff like that. You can build and test everything just as you would with a normal project, just by running it up and setting breakpoints and all the rest of the stuff, and that's cool. Getting it up there once you've done it locally, once you've built it and once you've deployed it and tested it, you can get it up to the cloud in all the usual platforms as a service ways. And this is the point of question.
Sorry, I was just going to ask about the functions then. So have you got a choice of languages then?
Do you get a choice of languages when you're writing your functions? Yeah. The short answer, yes. Depending on which provider you use, you'll get a different choice. So Azure, you support C#, F#, Node, Python. I'm not sure whether Go is supported yet, but I know they're working on it, and Java. Amazon supports a different, slightly larger set of languages. Google used to support only Python. I don't know whether they've expanded from that, but yes, generally speaking, the language you want to write it in is probably supported on a platform somewhere.
There's a huge learning curve.
No, there isn't. There's a slight mind shift in the way that you're hooking it together usually, because no function can run forever. That's the main thing you need to bear in mind is, if your function runs for more than 5 or 10 minutes, it will get killed. So, long-running processes don't happen. So you have to pick those apart. But in terms of the actual coding, no, it's just the language you're used to working in the way that you're used to. Was there a question about it?
Is it kind of the mindset change? You need to move more to a completely stateless and functional programming mindset to enable you to leverage this in an easier way?
Yeah, so we're saying, do you need to change the mindset to a sort of more functional, stateless, way of thinking? Yeah, and yes, that is very much what you need to do. It is all stateless, largely stateless, and yes, the more that you think about things in a functional way, the easier this will be, because you are effectively taking stuff and feeding through function after function after function after function. So if you do that in your code already, if you're using a functional programming language, this will be second nature to you. So was there a hand over there? No. There's a blinding light there.
Regarding the limits on sort of execution time and so on, some of the platforms, like FaaS, lets you decide that yourself. So like some people who are using it they've got like workflows where they need huge amounts of memory, they can kind of decide that. Other ones where they have very long run times, so you can choose to do that as well.
Okay, informational point there. Some of the providers, like FaaS, will allow you to do long-running jobs. There's places where it's useful. So once you've got your functions, your project running, you can get it up to the platform in all the usual ways. So you can literally just copy the files up through FTP or whatever. You can integrate it with Git, so when you commit to the deploy branch, it all gets built and dumped in for you. You can zip it up and throw it up there. In Azure, you've got these things called deployment slots, so you can have your main service running, you can deploy it up to a staging slot, check that it's working okay in staging, and then switch them around so that staging becomes live, and and then you can switch them back when you discover that actually you shouldn't really have done that. And this all works exactly the same as platform. Is there another hand over there? No. Okay. And as well as the whole functional thing, but you do have to start thinking in a very cloud-oriented way. You don't, in theory, even know what operating system you're running under there, so you can't rely on the fact that you've got a case-sensitive file system. You can't rely on any of the normal things you would think of having on a machine. So your storage becomes cloud storage, blob storage, what have you. Your cache, you won't, generally speaking, be using too much of the idea of having a cache on a local instance. You'll be using something like Redis. And your monitoring and logging, again, you don't have a server that you can monitor or log. You've got an unknown number of servers and containers and things underneath this that are coming and going all the time in theory. So you do have to hook that up to some sort of cloud-based monitoring system. So in the case of Azure, you'll enable Azure Insights or something, or Azure Monitoring, as I think they're going to be renaming it. And logging, sort of similarly, you won't just dump it to a log file on your hard disk. You'll have to go and stick it out somewhere persistent. That small caveat there is just that, if you're creating a database connection or something like that where it takes an amount of time to spin it up and then rip it down, don't do that in every function. Do rely on the fact that you can have a static global variable going on which will live on some sort of semi-persistent infrastructure. So yeah, the fun bits. Yeah.
Sorry, can I just pull you up on that point then? So to try and understand that a bit better, how does that semi-persistent infrastructure work? Where if you're writing your function, do you actually put stuff that actually does need to live in a long term?
Yeah. So yeah, okay. So yeah, the semi-persistent nature of it. Essentially, if you've got something that you want to store and don't want to lose, don't try and dump it to your file system, because you're effectively running on a temp file system there. The instance machine or container that you're running on could disappear at any moment. But what you can do is rely on the fact that there is an instance running underneath you and it will live for an amount of time. So if you've got an expensive object in code that needs to, you don't want to keep creating and destroying, create that once as a global, and that will at least then live for the amount of time that your ephemeral container or server is up, rather than having to keep, rather than having that overhead.
Yeah, something like a database connection then, is that something that you would...
So yeah, you would create, you would store all your information. You wouldn't store your information on a hard disk, you would store it in a database, but you would probably, the database connection object that you're using to connect to that database, you would just create once as a static global variable, even though you'll probably be running on several instances and will have several of those static global variables around. But you've got one per instance that you're running on then.
Is there some mechanism then within the execution of this very short-lived function that allows you to tie out to this extra resource?
So yeah, so when you're running your short-lived function, it's still running in your runtime. So whatever language runtime you've got there, it will have been run up just the once, and it will be hosting whatever your project is. So when you call a function, you're not having to, it's not like CGI in the old days where you ran up the whole executable and then took it back down again every time there was a request. Your runtime is there, and you're just calling into the functions on it. It's just that you don't know how long that's going to live for. Okay. But you can rely on the fact, generally speaking, that your runtime will be living underneath it and won't need you to sort of create things too often. So yeah, the fun bits, you can't lift and shift, as we discussed. The chances are that you can't take what you've written and move it straight to serverless. So you will have to rethink how you're doing things. The best ways to start are, simple background jobs can be very easily lifted and shifted as a general rule, as long as they're not, sort of too heavyweight. And if you've got a service-based architecture of any sort already, you can start picking out different bits of those services and moving those up one by one. But in an ideal world, you start thinking serverless from day one and build everything from that. There are still occasional performance issues. They're still trying to work on, all the cloud providers are trying to improve sort of their cold start times for the time when they do need to run up a container or a server. They try and keep warm instances available for you. If you suddenly flood your thing with a whole load of HTTP requests, it will take a few seconds to start responding to that and working out that all of a sudden you've got this thing. And you still have potential bottlenecks. If you're talking to anything that isn't serverless or at least very scalable, then there's only so far you can go before your non-serverless bits become a bottleneck. And the one that people always worry about, the denial of wallet attack, because you can scale as large as you want, and because you get charged by how much you use. If somebody comes along and you've got a public-facing API and somebody suddenly hammers that, then you could be looking at a very large bill. The good news is that generally speaking, if you ring up and talk to a person and say this is the first time this has happened and you're really, really very sorry, they will generally speaking not charge you for the whole thing, but you will probably want to wrap Cloudflare or some other denial of service protection around it, API management, and in some cases, it's actually better to run, a public API potentially just on a fixed size of instance where that you don't want to go more than a certain size, and actually just go back to the old platform as a service thing of limit how large I can go. There are ways you can limit. Oh, is it that time already? There are ways you can limit the cost per hour or the number of parallel functions running, but that tends to mean that you end up sort of suddenly your service shuts down. So there's better ways of handling it, and the whole event-driven thing is still has the usual event-driven problems. Right, and the end. So and more questions.
Really quick, like literally 60-second questions. We probably have time for a few.
And they're all thunderstruck and gobsmacked and not enough to write serverless functions before the end of the day. Yeah, okay.
Can you say anything more about the kind of specifics of what you've done, of languages you've used or systems you've implemented? What's worked really well?
Specifics of what I built. Personally, I would. First choice language, I am a C# programmer mostly, so I will generally write functions in C#. But I write quite a bit in Node just because sometimes there's an NPM package which does exactly what I want, and they don't have a .NET library for it, and that's the nice thing. You can mix and match. So if you can use the best language for the job, is a nice thing. And the way I tend to use it is I'll have lots of little services running lots of different background tasks, and then it works really well with if you've got a static website with running off an API behind. If you then expose your API as a serverless thing as well, then that's where the sweet spot comes. But if you then start digging into the whole durable functions and fan in, fan out, that's you can then start to get something a lot more complex going around that as well. And again, you can build that in pretty much whatever language you want. Okay. Any more? Oh yes, there is one behind the light there.
So I use serverless quite a lot as well. And you mentioned earlier about cold starts. That's mostly the problem of the infrastructure provider. But what can a developer do to help try and reduce the cold starts?
I know. Sorry. What can a developer do about cold starts? Not a huge amount. What some people do, if they've got, the biggest problem with a cold start is if you've got something that runs very infrequently. So if you've got a daily job, for instance, that you can always guarantee that that will run, and then the instance it was running on will get shut down at some point. Some people will actually just fire a polling request at that every so often just to keep it warm for the next time they run. That's the main thing you can do, and rely on the goodwill of the platform to keep improving that.
One more?
Well, time for one more, if anybody has one. Yep.
What about serverless and Louis? Is there an integration there?
So integration between serverless and what, sorry?
And Louis, Louis is the equivalent of Alexa or Alex on Amazon.
Oh right, the integration between serverless and Alexa. Yeah.
Louis is Microsoft.
Right, the Lewis, the language understanding service.
Yeah.
You mean, yeah. There's no immediate. Lewis itself is serverless in that you get charged effectively for usage, and in the Alexa world in particular, but also in any other world, so Alexa very much pushes you down the path of saying, okay, when somebody speaks to Alexa, they are expecting you to fire it off to a Lambda function. So that's why those have become entangled, is because Amazon push you down that. In fact, there's no reason you can't put any normal API behind there, but that's just the way that they build all their starter kits and stuff. So that's why serverless and voice seems to be tied together. Okay, that's probably it then.